Hello students, welcome to the class. So in the previous class, we were discussing regarding disproportionation reaction. What do we mean by disproportionation reaction? Reaction in which single reactant is oxidized as well as reduced. So it undergoes oxidation and gives one product and undergoes reduction also and gives another product. And I had given you an example. If I'm not wrong, the example was Cl2 plus NaOH. When chlorine reacts with concentrated sodium hydroxide in hot conditions, it gives NaCl plus NaClO3 plus H2O. So balance the reactions. For balancing here, oxygens have to be balanced first. Therefore, I will write 6 NaOH. So 6 means here it is 5 plus 1. So 6 here I'll write 3. Correct? So this is balanced. So we need to find the oxidation state of chlorine in reactant as well as product. So you can see here the oxidation state of chlorine here. It is an element. It is in elementary state. So oxidation state is 0. Correct? Okay, what is the oxidation state? See, this is ionic compound. So metal ion will have positive charge and this will have negative charge. So this in this NaCl, chlorine is having -1. Here, let us find it. Yes. So 1 is the oxidation state. Plus 1 into 1, that is 1 only. Plus X, I will keep it as it is, into 1 atom. Plus oxygen is -2 into 3 equal to 0. So it comes out to what? It comes out to X. 1 plus X minus 6 equal to 0. So -5. So what is the oxidation state of chlorine? It is +5 here. So chlorine is +5. So what is happening from reactant side? Chlorine, which is having 0 oxidation state, in one case it is becoming -1. So gain of electrons. Yes. And in another state from 0, it is becoming what? It is becoming Cl plus 5. That means loss of electrons. Loss of electrons. So gain of electrons is what? Reduction. And loss of electrons is called oxidation. Oxidation, right? So one chlorine atom itself is undergoing reduction as well as oxidation. So such reactions is called what? Disproportionation reaction. Right, it is called disproportionation reaction. I hope you have done it and you have got the same. Okay, fine. So moving to the next concept, probably the last part in this topic, that is balancing the redox reaction. Yes, next concept is balancing the redox reaction. And we have two methods here. One is oxidation number method, which was being developed by Johnson. And second one is ion electron method, or you can call it as half reaction method also, which was being developed by Jett and Lamb. So let us see what is this oxidation number method, how we can balance the redox reactions using oxidation number method. So the method of balancing the redox reaction by oxidation number change method, it was being developed by Johnson. And in this, what we do is the total increase in the oxidation number. The total increase in oxidation number must be equal to total decrease in oxidation number. Then means what? Electrons are balanced. Yes or no? So this means what? Electrons are balanced. So total increase in oxidation number should be equal to total decrease in the oxidation number. So this method, it is applicable for both molecular as well as ionic equations. And I hope you remember what do you mean by molecular equation and ionic equation. Yes, okay. And what is this ion electron method is? In this case, what we do is we split the redox reaction. Redox reaction is split into two reactions, two half reactions we call. And I have told you, we have seen what do we mean by half reactions. One is oxidation half and another one is reduction half. So it is split into two half reactions, oxidation half and reduction half. So let us see both the with one example each, both the methods one by one. Okay. So what is the first method I said? It is oxidation number method. Let me write it here. So it is oxidation number method. Okay, fine. So what we do here is, first what we write is, we write the skeletal equation. Yes, representing the chemical change. Suppose equation is given. The equation given is, I will write the equation, you can see here. Copper reacting with the HNO3, nitric acid, gives me copper nitrate salt, CuNO3 twice, plus NO2 plus H2O. So this is called what? This is called skeletal equation. Why it is called skeletal equation? Because electrons are not balanced. Unbalanced equation is called what? Skeletal equation. Okay. Further, so this is what? This is step 1. Write down the skeletal equation. The step 2 says that you assign the oxidation numbers to the atoms in the equation. Assign the oxidation numbers. Okay. I will write the equation once again and then we will assign. Okay. I'll write here. Cu plus HNO3 gives CuNO3 twice plus NO2 plus H2O. Okay. Now I have to assign the oxidation states. Let us assign it. Copper elemental state, it is 0. Okay. HNO3. Okay. Oxygen, I know it is -2, nitric acid, and hydrogen is +1. Then what is nitrogen? Can we calculate it? So +1 into 1 atom plus X into 1, I need not write it, plus -2 into 3 is equal to 0. So 3 2s are 6, -6 plus 1 is -5. So X is equal to what? It is +5. So nitrogen is +5. CuNO3 twice. See, twice it is. Looking at the, this is salt. Looking at the formula only itself, we can say. So here, Cu is +2. Okay. NO3 is minus. When total charge on NO3 is minus. So NO3 minus it is. So I'll find it on nitrogen. Oxygen is again -2. So X, that is 1 atom of nitrogen, -2 into 3 is equal to -1. So X minus 6 goes that side, 6 minus 1, 5. So nitrogen is having +5 charge and oxygen is having -2 charge, correct? Here NO2, NO2. So it is X plus -2 into 3, I'm sorry, -2 into 2 is equal to 0. 2 2s are 4, X minus 4 becomes X plus X equal to 4, plus 4 minus 2. And hydrogen here +1, oxygen is -2. So we have to assign the oxidation states of each of the atoms on reactant side and on product side. I hope this is followed. This is the second step, what we do. Then after assigning, the third step, what we do is identify which is undergoing oxidation and which is undergoing reduction. Now we know, what we know is oxidation is what? Oxidation is loss of electrons. So when electrons are lost, what will happen? Increase in oxidation number, correct? Increase in the oxidation number. Reduction is what? It is gain of electrons. When electrons are gained, there will be decrease in oxidation number. Decrease in the oxidation number. So identify it. So Cu from 0, it is becoming +2. So shall I write it here? Cu from 0, it is becoming Cu +2 in what? In CuNO3 twice. So it is becoming +2. So I will call this as equation 1. Second case, what is happening? Observe HNO3. Let us observe it for NO2. Yes, this is in a combined state. So I'll take this. So HNO3, I'll not consider this because here also nitrogen is +5. Here also it is +5. So HNO3, in this case, nitrogen here is +5. And in NO2, nitrogen is becoming what? +4. All this as equation 2. Okay, fine. Therefore, what can I say? From 0 to +2. So there is increase in oxidation number. Therefore, it is what? Oxidation. So increase in oxidation number of copper, it is 2 units per molecule, correct? Per molecule, 2 units is increasing. Is that right? 2 units per molecule. So it is what? It is Oxidation. HNO3, decrease in oxidation number is how many units? It is 1 unit per molecule. 1 unit. Yes or no? From 5 it is becoming 4. So 1 unit per molecule there is a decrease. Therefore it is what? Reduction. So here I can say increase in 2 units and here decrease in to 1 unit per molecule. Is that right? So this is third step. Okay. Fourth step what we do is complete the balancing by inspection. So observe, first balance those substances which have undergone change in the oxidation number, and then atoms except hydrogen and oxygen have to be balanced. Don't balance hydrogen, don't balance oxygen. Okay. So to make increase and decrease equal, so here it is increase in 2 units, here it is decrease in 1 unit. To make this increase and decrease equal, can I multiply equation 2 by 2? So here it is 2 units. If I multiply it by 2, it will become 2. Yes or no? So when we multiply it by 2, what will happen? This equation I will multiply it by 2. So it will become HNO3, 2HNO3 gives 2NO2. Correct? So when I do this, here 2 electrons will become, here also it is 2 electrons. Correct? Then you write that equation down. Complete equation. So first equation is Cu plus how many HNO3 now? 2HNO3 gives CuNO3 twice plus NO2 how many? 2NO2 plus H2O. So hydrogen and oxygen shouldn't be balanced. Okay. So balancing nitrate ions, hydrogen and oxygen, the following equation will be obtained. Last step. You balance nitrate ions. Yes, last step says final balanced equation should be checked. Okay, so let us balance this. Final equation comes out what? Here, NO3, how many are there? 2. And here also there are 2 NO3. Okay. Hydrogen, how many are there? 2. Here we have 2 hydrogens. Oxygen, check out. So balance that, you will get Cu plus 4HNO3 gives CuNO3 twice plus 2NO2 plus 2H2O. 2H2O. So this is the final equation, and this is what? This is balanced equation. This is balanced equation. Got my point? So this is called oxidation number method. It is called oxidation number method. We have one more method. The second method is ion electron method. So what does this ion electron method says? Okay. It was being developed by Jat and Lamiv. So first step says that write down the redox reaction in ionic form. So they have given equation I2, example I'm giving you, plus OH minus gives IO3 minus plus I minus plus H2O. So this is what? This is ionic equation. Now, what does second step says? Second step says that split the equation into 2 half reactions. Split them into 2 half reactions. Yes, that is oxidation half and reduction half. Reduction half. So if you observe here, I2 is becoming, so I2 here, let me write the oxidation states, 0. Oxygen is -2, H is +1. Here -2. So X plus -2 into 3 equal to -1. So -6. So here 5. 6 minus 1 is 5. So it is 5 here, plus 5. And here it is -1. Here +1, 0. So which is here oxidation half? I2 becoming iO3 minus is oxidation, yes or no? So I will split it. So I2 plus OH minus becoming iO3 minus is oxidation half. What is reduction half? I2 becoming I minus. I2 becoming I minus is reduction half. So we have split the reaction. You have to first split the reaction. Okay. After splitting the reaction, what we are going to do is balance each half reaction for number of atoms of each atoms. You have to balance each half reaction. Okay. So here, let us balance it and write. So I2 plus OH minus gives iO3 minus. So I2 is there. I will balance here by writing 2. Correct. So I will write here I2 plus OH minus gives 2iO3. 2iO3 minus, and how many oxygen? So I2 is becoming balanced. So 2 3s are 6. So I will balance it by writing 6 OH minus here. Is that right? Fine. Okay. This side, no need to balance. It is okay. I2 gives 2I minus. Balanced. So here there are 2 items. Here that I write 2. Now, if it is having OH minus ions, balance the atoms of oxygen, all the other atoms you have to balance. Then what we do is to balance hydrogen, oxygen, add water molecules to the side deficient in oxygen. So where oxygen is less, add water molecules there. So fourth step becomes, so I2, where oxygen is less, this side oxygen is less. Okay, I will not balance the oxygen here. I have not balanced it. So I will balance it by writing 2iO3 minus, yes, I will write here 6H2O. Okay, so here if it is 6H2O, 6 2s are how much? 12. So 12OH minus comes here. 12OH minus comes here. Yes, so adding OH minus, I'll get it like this. This side, nothing to worry. So I2 gives 2I minus. Next step, what we do is adding electrons to the side deficient in electrons. So where electrons are deficient, there I will add. See, this remains as it is. I2 plus 12OH minus gives 2iO3 minus plus 6H2O. And this side, I2 will form 2I minus when it will gain 2 electrons. So I2 will gain 2 electrons to form 2I minus. Is that right? Okay. Next, balance the number of electrons in both the half cell reactions. Now here see, from 0 it is becoming plus 5. How many electrons? 5. So here I will write, I am writing first half here. I2 plus 12OH minus gives me what? 2iO3 minus plus 6H2O. So 5 electrons, and here there are 2 electrons, therefore it becomes 10 electrons. And next half I am writing here only. I2 plus 2 electrons gives 2I minus. So I have to balance it again this side also. So 2 is here, I will write 5 here. Now add both the half cell reactions. Last step. Add both the half cell reactions. So what do I get? I2. Okay. So here I2 are there. Here 6 I2 are, 5 I2 are there. So 5 plus 1 becomes what? 6. Adding this and this have to be added. This and this have to be added. Okay. So 6 I2 plus 12 OH minus gives 2 iO3 minus plus 6 H2O plus 10 electrons. Okay, plus 10 I minus, 10 I minus, and here 10 electrons gets cancelled, plus I minus, 10 electrons gets cancelled. Yes, so here everywhere we have coefficient. Divide the equation by 2. We want lowest number, right? Divide entire equation by 2. What do you get? 2 3s are 3I2 plus 6OH minus gives iO3 minus plus 3H2O plus 5I minus. Yes. So this is called ion electron method. This is called what? Ion electron method. So this is how we balance the chemical equations using ion electron method and half cell reaction method. Half cell reaction method, that is ion electron method, also called as a half cell reaction method. And another one is what? Another one is oxidation number method. Yes, oxidation number method. So we can take one more example. See, if you better understand this, it becomes easy. Yeah. So we'll consider one more example by balancing by oxidation number method. So oxidation number method. Okay. I'll take the example and we'll discuss stepwise one by one. Fine. Okay. So the reaction given is Cr2O7 minus 2, it is chromate ion, plus SO3 minus 2 gives Cr plus 3 plus SO4 minus 2. This is the equation given. Balance the redox reaction by oxidation number method. So we'll go on stepwise. So what is the first step? What we will do? We will write the equation, skeletal equation, and then we will assign the oxidation numbers. So let us write the skeletal equation. CrO7 minus 2 plus SO3 minus 2 gives Cr plus 3 plus SO4 minus 2. So what is this equation called? This is called skeletal equation. So first step. Now what I will do, I will assign the oxidation numbers. Okay. Let me first calculate the oxidation numbers. So this is x into 2 plus minus 2 into 7 is equal to 2. Correct. So 2x minus 14 is equal to minus 2. So minus 14 goes that side. It becomes plus 14. So it becomes plus 12. So x will be what? It will be plus 6. Is that right? So chromium. Okay. And oxygen I know minus 2. Here I'm going to calculate for sulfur. So I will write x into 1 atom plus minus 2 into 3 is equal to minus 2. Fine. So x minus 6. 6 minus 6 goes there, plus 6. It becomes plus 4. So x is what? It is plus 4 here. Okay. Chromium plus 3 is given, and sulfur x into plus minus 2 into 4 is equal to minus 2. Minus 8 becomes plus 8. X is 6 here. Plus 6. So assign those oxidation numbers. I will write here. This is plus 6. This is minus 2. Here it is plus 4. And it is minus 2. Here it is plus 3. Here it is plus 6. And minus 2. So I have assigned the oxidation numbers. Is that right? Okay. What is the next step? What is the next step? Second step is you need to identify which is getting oxidized and which is getting reduced. So if you look at here, the reaction CrO2, what ion it is? Dichromate ion, Cr2O7 minus 2. In this case, the oxidation number is, observe here, Cr in dichromate ion, it is plus 6. And it is oxidant, I can say. It is oxidizing agent. Okay. And sulfite ion, SO3 minus 2 is becoming what? And CrO3 is becoming what? So it is becoming Cr plus 3 here. Here it is becoming SO4 minus 2. So what is happening here, if you carefully observe, Cr in this case, it is plus 6. It is becoming plus 3. Whereas sulfur here, it is plus 4. It is becoming plus 6. So just observe, from plus 6, it is becoming plus 3. From plus 6, it is becoming plus 3 means what? There is addition of the electrons. So there is gain of electrons, correct? And sulfur, from +4, it is becoming +6. That means there is loss of electrons. So chromate ion, it is undergoing what? Reduction. And sulfur, it is undergoing oxidation, correct? Therefore, I can say dichromate ion is oxidant because it helps in reduction, whereas sulfite ion, it is reductant because it helps in oxidation. Is that right? Okay. What is the next step? The third step is calculate the increase. Okay, we calculated the increase in and decrease of oxidation number and make them equal. So calculate the increase. Here, increase in oxidation number is by how many units? It is by, in reduction, I can write. In reduction, increase in oxidation number. Increase in oxidation number is by 3 units. Is by 3 units. And in oxidation, what is happening? In oxidation, there is a decrease in there is a loss of electrons, correct? So loss of electrons, therefore what is happening? So in reduction, in reduction, there is decrease in oxidation number. In oxidation, there is increase in oxidation number. Okay. How many units there is gain? So it is by 3 units, and here it is by 2 units. It is by 2 units. Yes. So we have to make them equal. So how to make them equal? We will write here. I'll take the next page. Okay. So what I will do is, we have to make the electrons equal. So in this reaction, you can see I've taken half of it. So I'll make it here only equal so that we will write overall reaction later. So here it is 3, here it is 2. So multiply this equation by 3 and this equation by 2. Correct? Okay. Before that, balance the reactants. So here Cr2 is there. Balance it by writing 2 here. Oxygen need not be balanced. Don't touch oxygen. And in this case, sulfur is balanced. So multiply this by 3. So what does equation for fourth step becomes? Fourth step, I'll write the complete reaction. You can see here. Cr2O7 minus 2 plus, when I multiply the second equation by 3, it becomes 3SO3 minus 2 gives 2Cr plus 3 plus 3SO4 minus 2. Okay. And this reaction is supposed to be in acidic condition. Yes. So therefore, ionic charges are not equal on both the sides. So ionic charges are not equal. What we do is, to make the ionic charges equal, you add H plus ions in the next step. Yes. So here I will write step 6. This is step 5. You add H plus ions on the left side to make charges equal on the left side. Okay. So let us add it and see. So what it becomes? Cr2O7 minus 2 plus 3SO3 minus 2. So I will write how many charges here. 3 2s are 6. So I will add here 8 H plus ions. 8 H plus ions. Correct? Then this side 2 Cr plus 3 plus 3 SO4 minus 2. Okay. Finally, count the hydrogen atoms and add appropriate number of water molecules on the right side. How many hydrogen atoms on the left side? It is 8 hydrogen atoms. So next step, what we will do is, we will count hydrogen atoms and add appropriate number of oxygen molecules on the right side. Okay, there are 8. So what I will do, Cr2O7 minus 2 plus 3SO3 minus 2 plus 8H plus, here 2Cr plus 3 plus 3SO4 minus 2. 8H plus means how many water molecules? 4 H2O molecules. I have to add. 4 water molecules I have to add. So this is what? This is balanced redox reaction. This is balanced redox reaction, that too by oxidation number method. Oxidation number method. So please do remember, in step 4 here itself we do the changes. Here, why do we add H plus ions? See, they will mention whether the reaction is taking place in acidic medium or basic medium. So if it is in acidic medium, yes, to make the ionic charges equal, we will add H plus ions on the appropriate side so that the total ionic charges on reactants and products become equal. Total ionic charges become equal. Yes, they should become equal. So I'll tell you how they are becoming equal. Okay, -2 plus -6 plus 8. So this is -8 plus 8, 0. Here it is 6, 3 2s is -6. So ionic charges have become equal, 0, 0. Yes or no? So to make that equal, how many are required? That many H plus have to add in acidic medium. But if it is in basic medium, instead of H plus, I will add OH minus ions on the appropriate side to make it equal. Understanding? So here it is becoming 0 means here also it should become 0. Already I know the charges. How many more required to make it 0? That much I have to add. Is that clear? So if the reaction is carried out in acidic solution, use H plus ions in the equation. And if basic solution, use instead of H plus, we'll use OH minus. 8 OH minus you would have used. And to balance that H plus or OH minus, you will add equal number of water molecules. Yes. So to make the number of hydrogen atoms equal on the two sides, you will add equal number of water molecules to the reactants or product side. So if you are balancing by writing H plus on product side, you will add H2O on reactant side. Now here what we have done, we have added H plus on reactant side. So I will add H2O molecules on product side to balance hydrogen and oxygen atoms. Hydrogen and oxygen atoms. Is that clear? Yes. So 9, 3 3s are 9. 9 plus 7 is how much? 16. So here you can balance it by writing so. Okay. So this is oxidation number method. Now even in half reaction method, yes, even in half reaction method, what happens here is half reaction method. As I said, half reaction method or ion electron method, you can say. In this case also we have two concepts. When I was discussing, I discussed in general. So here we will take concepts in specific. They may say acidic medium. They will give you the equation and say it is carried out in acidic medium. Or they will give you the equation and say it is carried out in basic medium. Okay, I will write the equation accordingly. Let us solve. We know the steps now. So what I will do is I will write the reaction here. Fe plus 2 reacts with Cr2O7 minus 2 dichromate ion to give Fe plus 3 plus Cr plus 3. Okay, so this is the reaction given. In the first step, what we will do? Separate the equations into half reactions. So we will separate them out like this. You do it this only. This is better way. Okay. For practicing. When we are doing questions, I'll tell you the easy methods of how we can proceed doing it. Okay. So what we will write here? I will write here oxidation half reaction. And here I will write reduction half reaction. Okay. Now see, we need to identify which is oxidation half and reduction half. So this is the first step. So Fe plus 2 is becoming plus 3 means what? Loss of electrons. So that itself is oxidation, right? So Fe plus 2 is becoming Fe plus 3. So this is oxidation. Loss of electrons, increase in the oxidation number is oxidation. Cr2O7 minus 2 is becoming Cr plus 3. In one of our previous example itself, we have seen what is the oxidation state of chromium. We have seen here in Cr2O7 minus 2, it is plus 6. We have already seen it. Correct? So here I will write the oxidation states. Fe plus 2 plus 3 is given. Here it is plus 6. It is becoming plus 3. And oxygen is what? Oxygen is minus 2. Is that right? Okay. Now what is the second step? The second step says, second step says what? Balance the atoms other than oxygen and hydrogen in each half reaction individually. Separately, you have to balance the atoms. Okay. If the half reaction is already balanced, keep it as it is. So observe this. Here there is one Fe ion. Here also it is one Fe ion. So it is already balanced. So I will keep it as it is. So Fe plus 2 gives Fe plus 3. Correct. But is this reaction balanced? Here there are 2 chromium, here there is 1. So I will balance it. Cr2O7 minus 2 gives 2 Cr plus 3. Now it is balanced. Yes. Oxygen shouldn't be balanced in the next step. What is the next step? So after you balance that, if the reaction is occurring in acidic medium, is it in acidic medium? Yes. So since the reaction is occurring in acidic medium, add H2O molecules to balance oxygen atom and add H plus to balance hydrogen atoms. So I will write here, to balance oxygen add H2O and to balance hydrogen add H plus. Okay, so let us see. Fine. So here, are there any H2 or H or hydrogens? No. So I will keep this reaction again as it is. Fe plus 2 giving Fe plus 3. Need not to be balanced. But here there are oxygens, right? So Cr2O7 minus 2. How many oxygens? There are 7 oxygen atoms. So on left hand side, there are 7 oxygen atoms. Therefore, on the right hand side, I will write, I have to balance it on the right hand side, right? So I will add, to balance oxygen, I have to add water. So I will add 7H2O. Correct? Yes, or I will indicate it by a different color so that we can distinguish it out. Okay, so I will add how many? I will add 7H2O to balance oxygen. To balance oxygen, I'm adding H2O. And now when I wrote H2O, hydrogen has to be balanced on the left. Therefore, I will write what? To balance hydrogen, add H plus. How many? 7 2s are 14. Therefore, I'll add here 14H plus. Understood? Here there is no question only because there are no hydrogen and oxygens. So to balance oxygen on the left hand side, on the right hand side, I wrote water, that many number. Now when I wrote water molecules, I have to balance hydrogen. So 7 2s are 14. 14H plus I have written. Okay, next step. Fourth step is balancing of electrons. Now to balance the electrons, add electrons to one side of the half reaction to balance the charges. Fe plus 2 becomes Fe plus 3 when it loses electron. Therefore, I will write Fe plus 2 gives Fe plus 3 when one electron comes out. Is that right? Okay. So oxidation half reaction, I'll write it like this to balance the charge. Is the charge balanced now? Plus 2 plus 3 minus 1 becomes plus 2. So on both the sides, charges are balanced. Now in the reduction half reaction, the net, how many positive charges are there? So minus 2, you can see here minus 2 and plus 14 charges. So 14 minus 2 is how much? Net 12 positive charges are there. Net 12 positive charges are there on the left hand side. And on the right hand side, 3 2s are 6. There are 6 positive charges on the right hand side. Is that right? Understood? 3 plus 3 into 2 is 6. Here minus 2 overall charge. 14 plus charges. 14 plus charges minus 2 charges means what? 12. So I have to balance where? On the right hand side. So how to balance? Cr2O7 minus 2 plus 14H plus. Yes. So here what I will do? Plus 6 electrons. So here 12 positive charges. I have to bring it to 6. Therefore, electrons have to be balanced. 2 Cr plus 3 plus 7 H2O. Now how many charges? 3 2s are 6 charges. Here 12 positive are there. 6 negative, it becomes 6. So both are balanced. Understood? Electrons only have to be written. You cannot write plus H plus here. Correct? So electrons have to be balanced. Last step, what we will do? We have to equalize. Here there is only 1 electron. And here how many are there? 6 electrons. Therefore, how do you equalize it? Balance the oxidation half by 6. Multiply the oxidation half by 6. So what do we get? 6 Fe plus 2 gives 6 Fe plus 3 plus 6 electrons. Yes. Now finally, no need to do anything here. Finally, therefore, add the two reactions. Add the two reactions. So let us see. 6 Fe plus 2 plus Cr2O7 minus 2 plus 14H plus 6 electrons cancel out, gives 6 Fe plus 3 plus 2Cr plus 3 plus 7H2O. Cleared with this? Understood? So this is how we do the half reaction method. Will balance the redox reaction in what? In acidic medium. Now let us see if it is in basic medium. Okay, half reaction method, it differs. Half reaction method in basic medium. Basic medium. Okay, so let me write the equation. The equation is MnO4 minus plus I minus gives MnO2 plus I2. Okay, so first only we will identify the charges. MnO4 x plus minus 2 into 4 is minus 8. Minus 8 equal to minus 1. 8 minus 1 is how much? 7. So what is the charge here? It is plus 7 on Mn. Correct? And this is minus 2. This is minus 1. Here x minus 2 minus 2. Minus 2 into 2 is minus 4. It becomes plus 4. So Mn becomes plus 4 and oxygen is 0. And here it is 0. Okay, fine. So we will identify it, and immediately what we will do? We will divide them into two halves. That would be better, right? So I am going to divide it into two halves. Fine. So what I will call it as? This I will call it as oxidation half reaction. And this I will call it as reduction half reaction. Yes? Okay. So oxidation half reaction and reduction half reaction. Identify which is oxidation and which is reduction. So what is happening here? MnO4 minus, the charge is plus 7. It is becoming MnO2 where Mn is plus 6. So plus 7 is becoming plus 6. Means what? Gain in electrons. Gain of electrons. So this is reduction. So reduction half I'll write MnO4 minus gives MnO2. This is reduction half. Write the electrons plus 7 and here it is minus 6. Sorry, plus 6. Okay. So remaining becomes oxidation. I minus is becoming I2. So see there, oxidation number, decrease in the oxidation number. It is oxidation. Oxidation half reaction. Write the oxidation numbers also. This is minus 1. This is 0. This is 0. Okay. What is the second step? The second step is to balance iodine atoms. We have to balance both the atoms except hydrogen and oxygen. So I will mention here first step. I will take second step. Now here it is I minus, here it is I2. What I'll do? 2I minus gives I2. Balanced? In this side, is it balanced? Mn1, Mn1. No need to balance oxygen. Okay. So MnO4 minus gives MnO2. So it is balanced. So I will not worry. Third step is what? To balance oxygen in case of basic medium. To balance oxygen atoms in the reduction. Now here, no need to worry. There is no hydrogen. There is no oxygen. So I will keep it as it is. To balance oxygen atoms, what we will do is in a basic medium, since it is in basic medium, what we had done in acidic medium, you can see here, we had written to balance oxygen, we had added water molecules, and to balance hydrogens, we had added H+. Unlike that, in this, if the reaction itself in basic medium, to balance oxygen atoms, add water molecules. Add water molecules on the right side. Okay, let me add MnO4 minus is there. Here it is MnO2 plus how many oxygens have to be balanced? Here there are 4 oxygens, here there are 2. So I will add 2 H2O. Correct. So I've added 2 water molecules. When you add 2 water molecules on the left side, on the right side you will add that many H+. that many H plus. Okay. So let me write it like this. It is MnO4 minus. So I have to add H plus. How many H plus I will add? Plus 4H plus. 4H plus. Now, as the reaction takes place in basic medium, therefore, for 4H plus, we will add OH minus ions to both sides of the equations. So for 4H plus, there are 4H plus, no? So to make it neutral, we will add 4H plus ions on OH minus ions on both sides. Therefore, I will write the reaction as MnO4 minus plus 4H plus 4OH minus gives MnO2 plus 2H2O plus 4OH minus. This is the step. So you have to add OH minus like this. Yes. So replacing the H plus and OH minus ions in water with water, what will be the resultant equation? 4H plus 4OH minus becomes what? So resultant equation becomes MnO4 minus plus 4H plus 4OH minus becomes H2O gives MnO2 plus 2H2O and 4OH minus. Remove that. How much will remain? 4OH minus will remain. Here 4H plus will become. So 2H2O cancels out. Only 2H2O remains. Yes. So this is the equation after balancing hydrogens and oxygens. Is that clear? See, 4H plus 4OH minus becomes 4H2O. 4H2O, here 2H2O. So remove 2H2O remains. And this 4OH minus remains as it is. So this becomes balancing for oxygen and hydrogen atoms in case of basic medium. This is how we are going to balance. Is that right? Okay. Then step 5. What we are going to do in step 5. So this is step 4, what we finished. Here, no need to do anything because it is already balanced. So in step 5, balance the charges. Correct? So here, 2I minus 1 iodide ion, it has to form I2, means neutral, means it has to lose electron. So since there are 2 iodide ions, it will lose how many electrons? 2 electrons. Let us see here, balance the charges. So here minus 1. Okay. So minus 1 is there and here minus 4. So we have to balance it. So let us balance. I will write MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus. Because there are 4, here there is 1. So this becomes plus 1. So there are 3 electrons have to be balanced here. This is minus 4. Here it is minus 1. So to balance that, I will write minus 3. So minus 1 minus 3 becomes minus 4. Here also minus 4. Yes. Equalize both the reactions. So here there is 2. Here there is 3. So oxidation half, multiply the oxidation half by 3 and multiply the reduction half by 2. Oxidation half has to be multiplied by 3. Reduction half has to be multiplied by 2. So it will come what? 6I minus gives 3I2 plus 6 electrons, oxidation half. Reduction half comes out to 2MnO4 minus plus 4H2O plus 6 electrons gives 2MnO2 plus 8OH minus. Correct? So this we have done. We have equalized the number of electrons on both the sides of oxidation half and reduction half of the reactions. Now lastly, what we will do? We will add the 2 half reactions. Both the half reactions we are going to add. So 6 electrons gets cancelled. So 6I minus plus 2MnO4 minus plus 4H2O gives 3I2 plus 2MnO2 plus 8OH minus. So this is in case of oxidation, half reaction method. In case of half reaction method, what we do in case of half reaction method, if it is acidic medium, what we will do? Just we will balance the oxygens by writing equal number of water molecules on the left side. So 7 oxygens have to be balanced. We'll write 7 H2O. When hydrogen head comes to be balanced, we will write so many required number of hydrogens as H plus on the other side of the reaction. This is in acidic medium. In basic medium, what we will do? In basic medium, to balance oxygens, we will add H2O molecules on the other side. Then required number of H plus ions on the other side, on the opposite side. But along with that, how many H plus ions you have added? The same number of OH minus ions you will add on both the sides of the reaction, that is reactant side and product side. Then now example here, it is 4H plus 4OH minus. It becomes what? It becomes 4H2O. Correct. And here it becomes 2H2O plus 4OH minus. So 2H2O, 2H2O cancels. What remains is 2H2O and 4OH minus. So this is what we do in basic medium. In basic medium, acidic medium, for balancing oxygen, write equal number of water molecules on the other side. For balancing hydrogen, write equal number of H plus ions on the other side. Basic medium, same thing. For balancing oxygen, write equal number of water molecules. For balancing hydrogen, write equal number of H plus ions. Then how many H plus ions you have written? That many OH minus ions on both the sides of the reaction. Then cancel out. See how many water molecules it forms. Remove out the common water molecules. Then you will get balanced oxygen atoms and hydrogen atoms for the reaction. So this is about balancing the redox reactions in first one is what? Oxidation number method and in half reaction method. And in oxidation number method also, if it is acidic medium, you will balance by writing H plus ions. If it is basic medium, you will balance by writing OH minus ions. Yes, H plus and OH minus you will write. Then equally you will balance the oxygen atoms. So this is balancing the redox reactions. Balancing the redox reactions. In the previous class, we have discussed regarding these reactions. I just failed to give you examples for these reactions in terms of redox reactions. See, we just discussed here the examples we had taken. For all reactions also, on these reactions, I had not taken the examples. Disproportionation, we have done it very beautifully, but I would like to give examples for all these reactions to make you all understand what do we mean by these terms. Because regularly when we speak about decomposition reaction, general reaction, if you say, not redox, okay. If you say decomposition reaction, we say breaking off the compound into two compounds. Two simple compounds. Combination of two reactants to give one product. Displacement, metal displacement. Disproportionation, one oxidation and another reduction. But when we speak about these reactions in terms of redox reactions, then we have different examples to understand the concepts. Okay, so what are those different examples? So when I talk about types of reactions, yes, we already know the definitions. I'll just go on giving you the examples. First one, what we had discussed was decomposition. I'll not just say it as decomposition reaction. I'll say decomposition redox reaction. Decomposition redox reaction. Okay. So in a redox reaction, there should be decomposition. So how do we understand it? Decomposition reaction leads to breakdown of a compound. Suppose a compound is there. It breaks down into two simple compounds. Okay. Into two or more components. It might be more also. One of which must be in elemental state. One of which must be in elemental state. So one of which you get two products, one should be in elemental state. You get three products, one should be in elemental state. Okay, I'll give you the example to make you understand this. Now see, H2O in liquid form, it decomposes to give me H2 plus O2 in gaseous forms. Both are in gaseous forms. Both are in gaseous forms. Okay, fine. So balance this reaction first. So it is H2O. I'll write 2 here and I'll write 2 here. So what do we mean by decomposition? Observe the oxidation states. Here hydrogen is how much? +1. Oxygen is -2. Here hydrogen is 0. It is also 0. So what is happening? From +1 it is becoming 0. From -2 it is becoming 0. So it comes into, one of them comes into elemental state. Here both have come into elemental state. Not a problem. Take another example. One more example, NaH gives Na plus H2. Yes, so I will balance by writing 2 here, 2 here. You have to write the decomposition, redox reaction also here. So one has come into elemental state. Yes, this is also elemental. So 0, 0. Here Na is plus 1, hydrogen is minus 1. Because when hydrogen combines with a metal, hydrogen becomes hydride. What it becomes? Hydrogen becomes hydride. Therefore, H will get minus 1 oxidation number. Okay, fine. Another example you take. KClO3 gives KCl plus O2. Now see, this is in ionic form, but oxygen is in elemental form. So one of the product will be in elemental state. So this is elemental 0. Here K plus Cl minus 1. Here it is K plus 1, oxygen is minus 2. Find it for Cl. Plus 1 into X, plus 1 into 1 plus X, 1 atom. Minus 2 into 3 is how much? Minus 6. So minus 6 plus 1 is minus 5. So X is equal to what? It is plus 5. It is plus 5. Here it is minus 1. So this is how we explain decomposition redox reaction. Second reaction, what we had studied? We had studied combination redox reaction. So what happens in combination redox reaction? There is combination. Okay. So there happens combination of the reaction. Combination means what? Two or more compounds combine to form a product. Two or more compounds combine to form a product. And there should be redox reaction. One should be oxidized, one should be reduced. Getting my point? Okay, let us take example. Carbon plus oxygen. So combination reaction which makes use of elemental oxygens, or almost all combination reactions make use of elemental oxygen, you can say, or it may use nitrogen. Okay, let us see. Gives CO2 and it should be redox. Let us verify it later. One more example, magnesium plus nitrogen gives magnesium nitride, Mg3N2. Then another example I can take, CH4 methane undergoes oxidation to give CO2 plus H2O. Okay, so balance it, CO2 it is balanced, Mg3 and N2. So Mg3 Mg, so I'll get this CH4 2 I will write here, 2 2s are 4, so 2 I will balance. Okay, let us see whether it is involving redox reaction or not. Carbon 0, oxygen 0. Here oxygen is minus 2. Minus 2 into 2 is minus 4. So carbon is plus 4. Correct? Okay. So from 0, it is becoming plus 4. Oxidation. From 0, it is becoming minus 2. Reduction. So it is redox reaction. Mg0, N2 0. Here magnesium is plus 2. Nitrogen is minus 3. See, plus 2 into 3 is minus 6. Minus 6 goes that side. Plus 6 goes that side, becomes minus 6. Minus 6 divided by 2 is minus 3. So zero oxidation state, magnesium is becoming plus 2. And 0 oxidation state, nitrogen is becoming minus 3. So what is happening? Plus 2 means oxidation. Minus 3 means reduction, gain of electrons. Yes. CH4, carbon, this is, here we have plus 1. And carbon is what? It is 4. So it is minus 4. Oxygen 0. So when hydrogen is bonded to non-metal, hydrogen will have plus charge, carbon will have minus. Here carbon dioxide, oxygen is minus 2. Minus 2 into 2 is minus 4, becomes plus 4. Okay. Then H2O. This is plus 1, this is minus 2. So from minus 4, let us take for carbon, minus 4 is becoming plus 4. So it is loss of electrons, oxidation. Or hydrogen plus 1, it is remaining same. So it is a spectator ion, correct? Oxygen, in one case from 0 it is becoming minus 2. Here also from 0 it is becoming minus 2 means what? Reduction. Yes. So all are redox reactions which involve combining of the two reactants to form one product. So that is what? Combination reaction. Third, what type of reaction we had seen? Third one was displacement reaction. Displacement reaction. And in displacement redox reaction, let me be very clear. Redox reaction. In a displacement redox reaction, we have discussed metal displacement reaction and non-metal displacement reaction. So metal displacement reaction, redox reaction, and non-metal displacement redox reaction. So displacement reaction means what? An atom or an ion of a compound, it is displaced by another atom or another ion. Okay, and that depends upon the reactivity. If the atom is more reactive, let me say I'll give you a general reaction. I will write the reaction like X plus YZ gives me XY plus Z. Sorry, XZ plus Y I will write. Okay. So if this atom X is more reactive, then only it can displace Y from the other compound. If it is not reactive, it cannot displace. Depending on that, we have metal displacement and metal non-displacement reactions. Okay. Let us see an example. Here, copper sulfate plus zinc gives me what? Gives me zinc sulfate plus copper. So copper being more reactive than zinc. Zinc being more reactive than copper has displaced copper from its solution. Is that right? Write the charges. Let us see. CuSO4. Okay, Cu plus 2. Sulfur, I'll check. This is minus 2. So my plus 2 plus X minus 2 into 4 is minus 8. So minus 8 plus 2 is minus 6. So sulfur is plus 6. Is that right? Zn elemental state 0, copper elemental state 0. Here again it is plus 2. This is minus 4. Sorry, minus 2. So plus 2, same thing, plus 6. Correct? What is happening? What is happening? Observe here. So let me write it here. Copper from plus 2, it is becoming 0. So gain of electrons, reduction. Yes or no? Gain of electrons. And sulfur is remaining same. So it is a spectator ion. Oxygen, zinc. Oxygen is also remaining same. So SO4 minus 2 is a spectator ion. I can say zinc from 0, it is becoming plus 2. That means loss of electrons, oxidation. So it is redox reaction. Okay. Take one more example. The other example is FeSO4 plus zinc gives ZnSO4 plus Fe. See, since Zn is more reactive than iron, it can displace iron from its solution. Okay, it can displace iron from its solution. So I'll write it here, Zn being more reactive than iron. And here, zinc being more reactive than copper. Okay, fine. So let us write the charges. FeSO4, sulfur is always plus 6. Oh, this is minus 2. So plus 6 minus 8 becomes what? Plus 2. So Fe is plus 2. Zinc 0, here iron 0. Zn plus 2 plus 6 minus 2. So SO4 minus 2 I will not consider. Fe from plus 2, it is becoming 0. Gain of electrons, reduction. Whereas Zn from 0, it is becoming plus 2. So loss of electrons, it is oxidation. So it is a redox reaction where there is displacement of an atom or an ion from another atom or ion into its solution. Non-metal displacement reaction. In a non-metal displacement reaction, what happens? A non-metal present in a compound gets displaced by a metal or a non-metal. So a metal or a non-metal can displace this. And usually in non-metal displacement reactions, there is evolution of hydrogen gas. Let us see. Na plus H2O. So a non-metal has to be displaced. Which is the non-metal here? Oxygen has to be displaced. So it will be displaced by whom? It will be displaced by sodium. Right? So what do I get? I will get NaOH plus H2. NaOH plus H2. So let me balance it. 2 2s are 4. So 2 here, 2 here. Correct? Now write the oxidation states. Let us see. 0. Here it is 0. Plus 1 minus 2. Plus 1 minus 2 plus 1. Correct? Okay. So what is happening? Observe. Na from 0, it is becoming plus 1. So loss of electrons, oxidation. Oxygen is remaining minus 2 only. Hydrogen from plus 1, it is becoming 0. So it is reduction, gain of electrons. Similarly, one more example you can consider. Mg plus HCl gives MgCl2 plus H2. Okay, so let us write the charges. Mg0, H2 0. Here H plus 1, minus 1, plus 2, minus 1. Okay, so write it here. Mg from 0, it is becoming plus 2. Loss of electrons, oxidation. Cl is remaining same. H plus 1, it is becoming 0. Gain of electrons, reduction. So both oxidation and reduction is there. So it is a redox reaction, which is non-metal displacement. So non-metal has been displaced. See here from its solution. And most important is what? Most important is in a non-metal displacement reaction, there is evolution of hydrogen gas. There is evolution of hydrogen gas. And we have seen disproportionation reaction. Disproportionation reaction. What happens in disproportionation reaction? One same element gets reduced and gets oxidized. Yes, I'll give one more example if you want. Sulfur plus OH minus gives sulfur minus 2 plus S2O3 plus H2O. Balance, I will first give the balanced reaction only. 12 OH minus gives 4 sulfur. Yes, I will not mention this. 4 sulfur plus 2 S2O3 and 6 H2O. So here sulfur is 0 and here it is S minus 2. Okay. Oxygen minus 2, hydrogen plus 1. Okay. Here, let me keep it as X, 2X plus minus 2 into 3 is minus 6, goes that side plus 6. So X will be 3 plus 3. 3 2s are 6, 6 by 2. So S will be plus 3. Oxygen is minus 2 again, plus 1, minus 2. So what is happening here? Sulfur, you can see, sulfur from 0, it is becoming S minus 2. So gain of electrons, reduction. Sulfur 0 is becoming plus 3. Loss of electrons, oxidation. So these reactions are called types of redox reactions, which involve both oxidation and reduction, and there is decomposition. That means breaking down of molecule into 2. Combination, that means combination of 2 into to give one product. Then metal displacement, non-metal displacement. In metal displacement, more reactive metal will displace the less reactive from its solution. In non-metal displacement, there is evolution of hydrogen gas. And last one is disproportionation reaction. Okay. In this chapter, what is left at the last is you need to understand regarding the redox reactions as basis of titration. Redox reactions as basis of titration. Titration means what? See, it is a quantitative analysis. You will find the quantity, amount of the substance by redox reactions. Okay. So titration process, it includes what? It is a quantitative analysis in which quantity of some substituent you want to find. You will determine it by adding to the measured sample, that is known sample of another. And you'll be using here, you'll be using burette, pipette and all. That is titration. Okay. In the redox reactions, So I will write in redox reactions. These come under second PUC practicals. Okay. Titration method can be adopted to determine. So you can use titration. For what reason you use? In the case of acid-base titrations, we will use the titrations to determine the strength of acid or base. In redox reactions, titration can be adopted to determine the strength of oxidant, that is oxidizing agent, or reductant, that is reducing agent. Yes, and you use, for that you use what? You use some chemical compound called redox indicator. You use a chemical compound called redox indicator. Yes, I'll tell you what all we do here. Yes, I'll show you in the form of a block here. Okay. I'll tell you the examples using this block. Fine. So here, okay. So here I'll mention what titration I'm speaking about. Yes, we'll carry out what type of redox titration. What is the indicator used? What is the color change? Okay, so this is the last part. So titration, KMNO4 versus oxalic acid. Oxalic acid. Indicator, KMNO4 itself acts as indicator, so I can say it is a self-indicator. The color change will be colorless to pink. Colorless to pink. First example. Second example, K2Cr2O7 versus we use Morse salt. K2Cr2O7 versus Morse salt. Yes, Morse salt is a double salt. It is NH4 twice, FeSO4 twice, 6H2O. That is Morse salt. Here indicator used is diphenylamine. Yes, and the color change is from green to blue. For this redox titration, we use diphenylamine where the color change is green to blue. And last one is iodine versus thiosulfate. Thiosulfate. The indicator used is starch. It is starch and the color change is blue to colorless. Blue to colorless. So please do remember these indicators and for redox reactions, we use these indicators. Why? To find the strength of the oxidizing agent or the reducing agent. And these are the color changes. These are the color changes. What color? For KMNO4 versus oxalic acid, self-indicator we call it as. We call it as self-indicator. KMNO4 itself acts as indicator. Colorless to pink we get. Change in the color. K2Cr2O7, potassium dichromate versus Morse salt. Diphenylamine is used as indicator. We get green, from green to blue. Iodine versus thiosulfate. We use starch as an indicator. We'll get color change from blue to colorless. Yes. So this is all about redox reactions. In the next class, we will proceed with the multiple choice questions regarding the redox reactions. Yes. So this is all about the redox reactions, what all we have discussed. In the next class, I will proceed with multiple choice questions. For now, thank you.